Hey, geometry. I'm recording section 7-6. Yesterday, the fifth period class got a little bit farther than the first period. So if you are in the fifth period class, go ahead and skip through this video until I get to example, I don't know, whatever it is, example 6. Okay, so skip through until I get to example 6. But first period, this is for you. First period yesterday, we talked about these three things, and we talked about isosceles trapezoid versus a regular trapezoid. So like in this diagram that we have right here, the legs are not the same length. They don't have a marked, like with those little tick marks. So he is just a regular trapezoid versus these three are all going to be isosceles trapezoids because they have these little tick marks here. And when that happens, we have that the angles are the same. We call those base angles. This one, your bases are the left and the right hand side. Your bases are the ones that are parallel. And then this one is talking about the diagonals. And we've done this before, how those diagonals are going to be exactly the same length as long as it's an isosceles trapezoid. Okay, so we skipped example 1, but we went straight to example 2. And if we plot these points, I'm going to do that real quick. So put these vertices on this coordinate plane right here. So let's do -8, -4 is this guy, -8, -4. It's hard for me to write. All right, 0, 8, 0, 8, and 6, 8. And -6, 10. No, -6, -10. Okay, so I've got something that looks like this. There we go. Okay, so first things first, it says show. They want us to show that this is a trapezoid. Okay, in order for this thing to be a trapezoid, all I have to say is this guy has the same is parallel to that one. And when we're looking at parallel, we're looking at slope. So I'm looking at like this coordinate to that one. You can do the slope formula like y2 minus y1 over x2 minus x1, but I'm just going to count how many boxes there are. So this one from here to here is going up 1, 2, 3, 4, 5, 6, up 6 and over 1, 2, 3, 4. So up 6 and over 4. That is his slope, which reduces, if you divide by 2, is 3 over 2. Cool. This bottom one right here is going up 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1, 2, 3, 4, 5, 6. So this guy's slope is 9 over 6. Ugh. Which, if you divide by 3, is 3 over 2. So those two have the same slope. Cool. That means he's a trapezoid. Check. Done that point. Now they want us to see whether it's an isosceles trapezoid or not. In order for him to be isosceles, these two sides would have to be the same length. So in that case, we're not looking at slope anymore. Now we're looking at distance instead. So we're going to do the distance formula. So here we go. Distance formula, this guy squared plus this guy squared. And we are looking at the difference between 0 and 6, which is, actually, you know what? That was silly. Why did we do the distance formula? We can just count. That is 6 across. But, okay, there we go. We have to do the distance formula for this one, though, because he's slanted. This is 6 units, even though there's 3 spaces, 6 units. It's going by 2s. All right, let's do distance formula for this guy, because he is slanted, so we have to do it. That was silly before. Okay. This guy squared. All right, so here we're going from -8 to -6, which is 2. And then we're going from -4 to -10, which is 6. So 2 squared is 4, 6 squared is 36, and if I add those two together, that will be the square root of 40, which is not exactly the same as what 6 is, right? The square root of 40 is not exactly 6. So that means that this length right here will not be the same as this one. So yes, he's a trapezoid. Check, we checked that one. But he's not an isosceles trapezoid. Those two sides are not the same. Not isosceles. Okay, there we go. So that's how we check that. Slopes for the two bases, and then the other two are just going to be distance formula. All right. Okay, let's do some other things here. They're talking about mid segments of a trapezoid, mid segment. So what they've done here is for this guy, here's my trapezoid. My bases are these two, okay? And then what they say right here is they find the midpoint here. Like U is exactly in the middle from T to P. R is exactly in the middle from Q to S, okay? They found those middle and they connected those. And that's what's called the mid segment. We wrote that down on your little sheet yesterday. Okay, this length here is 18, this length here is 11, and we know from the mid segment that this is just going to be the average of those two. So if I take 11 and I add 18, that is 29. And if I take 29 and divide by 2, I get, I don't know, like 14 and a half, I think. 14.5. That is the length of that mid segment. He'll be exactly that length. Okay? So that's what they're asking for on example 3. And then example 4, they turn it around a little bit on us. And instead of having us find the length of the mid segment, they tell us that the mid segment right here is 24. And they're wanting us to find this guy, this top guy. Okay? So I know that if I take the two bases, so x plus 16.7, the top and the bottom, those are my two bases, and I divide that by 2, that has to be equal to 24, okay? But I'm going to do something really easier than that, okay? So this is the formula. This was how you would normally go about if you were trying to solve for this 24, right? Okay, so you could undo this, and you could multiply the 2 over and do all that stuff, blah, 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 whatever. But I don't want to do that. I'm going to say that 24, this length right here, has to be exactly the midpoint or the average, exactly in the middle of those two numbers, right? So like, how far apart is 24 and 16.7? If I were to subtract them, 24 minus 16.7, I think is like 7.3, right? So I know that whatever this number is, 24 has to be 7.3 away from that. So let's just take 24 and add another 7.3 to it, and I get 31.3. And that is much faster than doing this whole formula backwards, right? We just subtract them. How far apart are those two? Well, then that's going to be that distance as well, and then just, add it to the 24 to figure out what the top number is, okay? So that works as well, doing it that way, all right? Let's look at example 5. This is the last one that we did that the 5th period class did that we have not done yet. So they are saying if this is a trapezoid right here, and AD, which is this guy, is parallel to BC, so it's the left and the right sides that are my bases, they want me to find the end points of the mid segment. Okay, so my mid segment is going to go like from here to here-ish, something like that. They want me to find this point right here and this point right here, wherever those are located. Okay, and what I know to be true about this point is that he is the midpoint from here to here. Whoop. From here to here. He's the midpoint. And finding the midpoint is like finding the average, right? We average the x's together. So I average 0 and 18 together. If I add 0 plus 18 and I divide by 2, that's going to be 9, right? 18 divided by 2 is 9. If I add 8 and 8 together, that's 16, and 16 divided by 2 is 8. Okay, now you probably could have figured that out on your own, that that's going to be 9 comma 8, right? Like half the distance across, 9 comma 8. But when it's slanted, it's a little bit harder. You're trying to average 1 comma 4 and 20 comma 0. So average means add them together and divide by 2. I'm going to take 1 plus 20, and that's 21, and 21 divided by 2 is like 10.5, I believe. 21 divided by 2. Same thing with 4. I take 4 and add it to 0, because I'm finding the midpoint, I'm finding the average. 4 and 0 added together is 4, divided by 2 is 2. So 10.5 comma 2. Oh, my point should be right there instead. Okay, a little bit over. So this is what my mid-segment is going to look like, but it's asking for the end points of the mid-segment. So 9, 8, and 10.52. That is where these dots are going to be located so that my mid-segment can be drawn just like that. And now, one thing I don't think that we did talk about yesterday was that since we know that this base is parallel to this one, but also the mid-segment will be parallel as well. So those three lines will actually all three be parallel. So that's kind of fancy. But anyway, that's what they're asking for, is just those 2 points. Okay? All right. Now, fifth period. Hopefully you are catching back up to me and or finding this spot where we're leaving off. We're going to do kites next, but before we do kites, I'm going to have you fill out this thing. You have this little bottom piece on your grid of 6 boxes. I only copied and pasted the one box over here because I'm recording this on my different computer. But we're going to fill this box in, then we're going to answer some kite questions, and then we will be done. Okay, drawing a kite is hard for me to draw. So what I'm going to do is, this is the easiest way I can tell you to draw a kite. We're going to draw a T like this and like that-ish. Okay, so make sure he's like a perfect T or like a cross. And then we're going to connect here to here, here to here, here to here. That's the easiest way I can tell you to draw a kite, is to draw a T first. I don't know. Maybe you have a better way of doing it, but that's how I draw a kite. Okay? All right, so here's my picture. Go crazy. I don't care. Are you done drawing your kite yet? I don't know. How many little bow ties is he supposed to have? Probably only 3. Whatever. There's my kite. All right. The sides of a kite. What is true about the sides of my kite? All right. I know that like he's so one other thing about a kite is that he's not a parallelogram, right? The opposite sides aren't parallel. In fact, none of the sides are parallel. Like this guy's not parallel to this one. That's not going to work, right? And the other 2 are not parallel as well. So he has no parallel sides at all. Nothing. So what's true about the sides? Well, this side is going to be the same as length as that one, and then this side is going to be the same length as that one. So let's call those, since they're right next to each other, let's call them consecutive because they're right next to each other. So for sides, let's say 2 sets. I'm going to say consecutive sides. Consecutive sides are congruent. 2 sets of consecutive sides are congruent. The top 2 are congruent, the bottom 2 are congruent. They're the same length. Okay, let's talk angles for a second, okay? So like this angle up top here, I don't think he's going to be the same measure as this bottom one down here. This one looks like maybe a 90-degree angle, and this is way less than that. But what is true is that this angle will be exactly the same as this one, okay? So these 2 will be the same, but the top and bottom will not necessarily be the same. In fact, they won't be the same if it's a kite. It would have to be a perfect like square. Like this side would have to come like this. Ooh, that was really bad. In order for this to be the same as that. All right, so, and that's not true in this case. So just one set of angles are congruent. I'm just going to say one set of congruent angles. Okay, and you can say that they're the left and the right set, but sometimes your kite might be laying on its side. Okay, so not necessarily the left and the right always, but in this case it's the left and the right. Okay, and then the diagonals. Okay, the diagonals don't necessarily bisect each other, although this is going to be the same length as that. So it does bisect this one, but it doesn't bisect the up and down one because this is not the same length as this one. Like that's not true. Okay, where's my undo button? I don't have an undo button. I don't like that I don't have an undo button. I have to erase everything. Silliness. Whatever. Okay, but what is true about a kite and the diagonals of a kite is that they are perpendicular. they form a 90-degree angle when they cross each other. That's like the posts of your kite that you put together, right? So the diagonals, I'm just going to say diagonals are perpendicular. The symbol for perpendicular is that upside down T. So diagonals, perpendicular. There we go. Okay, so that's information that you need to write down in that little box. My picture, I moved him off to the side over here, but that's fine. Let's go answer some questions about him. So I'm going to scroll back down, make you dizzy. Sorry, look away. All right, here we are, example 6. This stuff right here was the stuff that we just got done writing down on our little cheat sheet. And here we go. They say find the measure of angle N. I like this question. Right off the bat, they're giving you some interesting information. So my kite, the T of my kite goes like this, right? That's what my T looks like. Ugh. So anyway, my kite is kind of tilted to the left. So here you can see what we just talked about is that top and bottom angle are not necessarily going to be the same, but we do know that this left and right side angle are going to be the same. So that's kind of fancy. Let's do this. All 4 angles together, because this is a quadrilateral, all 4 angles inside of them is going to add up to be 360. So if I add these two together, 71 and 52, that is 123. And then I can subtract from 180. 180 minus 23 is like 57, I think, if you subtract those two. And that means that these two right here should end up being adding up to be 57, but since they're both the same, I can just take 57 and I divide that by 2. And that is going to be like 28 and a half, I think. So it's not going to come out nicely, but that's okay. 28.5 degrees is what each one of those angles is. And they were just asking for angle N, but L will be the same as that. So 28.5 degrees is what he will be. Okay? All right. The check, I'm not going to go through the check, but the check would be exactly the same. That does not look like a nice looking kite. This side looks way different than that one. I don't know. That makes me dizzy. I can't look at that. But to solve for F, it would be the same way. You would add these two together, subtract them from, wait a second. I did not do that right. Are you yelling at me yet? Are you yelling at me? I said you subtract it from 360. For one thing, that does not look like a 28.5 degree angle. I don't know why I didn't just check that. We're supposed to subtracting from 360, not 180. Are you yelling at me yet? You have permission to yell at me. Okay, 360 minus 123 is 237, I believe. Add that back in my head. Yep, 237. Now I divide that by 2. That sounds better. Is 118.5, I believe. Somebody check that though and make sure. 118.5. That sounds better and that looks better. That angle is definitely 118 degrees and not 28 degrees. Woo! Okay, so there you go. See, look. We fixed it. All right, there you go. So yes, same thing with this one. Add those up, subtract from 360, and then divide by 2. Okay, but example 7 is now going to talk about the lengths. So like 6 is measuring from here to here. 12 is measuring from here to here. So you can see here that this diagonal is split in half, but this one's obviously not. Okay, and don't think that I understand that 6 is a 1/4 of 24, but that will not always be the case. Okay, so don't think that that's always like this is always 4 times larger than what this one is. That is not necessarily true. Okay, you could have a kite that's really short or you could have a kite that's really long. It doesn't matter. Okay, but your left and your right side diagonal should be the same. They want us to find AD, which is this guy. How the heck do we find that? Well, we know that this is a 90-degree angle, which means that this is a right triangle, and we can use the Pythagorean theorem. So my side C is going to be the side that we're looking for. That's going to be my AD side. So I can do 12 squared plus 24 squared, and then solve for my C squared. 24 squared. I don't know that I remember. It's like 676 or something is sticking out in my brain. I know that this is 144 plus, let me get my calculator out. I don't think that's right. 676. 576. I was wrong. 576. And that's what c squared is. So then if I add 144 to that, I get 720. So this is 720. And I'm going to take the square root of that, and we're going to, yeah, they have it right here. The square root of 720, which is 12 square roots of 5. I'm going to actually give it as a decimal because I want to know exactly how much it is. So, come on. I have my phone calculator. The square root of 720 is 26.8. We'll go to one decimal place. So 26.8 units, whatever the units are, inches, I have no idea. 26.8, using the Pythagorean theorem. That's what this side is, okay? And, hey, that was it. Perfect. Look at that. Example 7. We're all done. Okay, this check would be the same way. They're finding CD, and CD is this guy right here. But since we know that this is 5, this side would also be 5, so you're doing the Pythagorean theorem with those numbers, okay? On the practice, I know that we did 2 through 4 yesterday for homework. Maybe first period, you don't know that yet. 2 through 4, and then 6 through 11, I think is what I told you to do. Do all of those, but I'm going to add to that the kite problems. Let's do 13 through 15 and 18 and 20. Yeah, 13 through 15 and 18 and 20. 13 through 15 all, and then 18, 20. That looks like a B. Sorry. 18, 20. Okay. There we go. All right, so work on that for homework. You got probably a lot of time in the class period to get that done. So there you go. And I will be back tomorrow to go through, we'll start chapter review tomorrow. I warned you that we were going to take a quiz over that grid that has all of these guys on it. But that won't be tomorrow. We'll review for the chapter first, and then we will take a quiz over that right before we take the test. Okay? All right, that is all I have.